All right. Graphing a line. Lots of ways to approach these problems. Let's talk about the point slope form. This is y equals m, x minus x1 plus y1. A couple things that we could do here. Number one, we already know one of the points. Automatically, I'm going to look for my x1 and my y1. I've got this 4 and the 2. So I know that there is a point on the graph 4, 2. Don't make the common mistake of putting negative 4. Even though this says x minus 4, notice that's part of the equation, the x minus. The x1 is without the negative sign. So if I had a positive number there, then you could put a negative x, but I don't. So the point I know is 4, 2. I'm going to graph that first. 1, 2, 3, 4, 1, 2. Now, lots of different ways to get other points. One of the first ways is to look at the slope. 0.75. Well, I can go up 0.75 and then over 1, but that's a little bit harder. If I want, I could throw this in my calculator, or you may just know off the top of your head that as a fraction, that's 3 over 4. So I could rise 1, 2, 3, run 1, 2, 3, 4, and get to another point. That would be using my slope. I could then go down 4 and back 4 and come up with another point. Another way to find extra points on this graph is to just choose a value. Let's say, hey, I want to find the y-intercept. I know that at the y-intercept, the x value is 0. So if I take and plug 0 into this equation, 0.75 times by 0 minus 4 plus 2, it should get me the y value that goes with that. 0 minus 4 is negative 4, times 0.75 will give me negative 3, add 2 and I get negative 1. So I know I have a point at 0, negative 1. All right. Two different ways to find extra points on this graph and connect our dots. So it said to make sure to label 3 points. I've got 0, negative 4. I've got 4, 2. And then I have 8. What was that? 8, 5. 1, 2, 3, 4, 5.